Hello and welcome to another video of this series about object-oriented programming. In this video I'll introduce class member variables denoted with the static keywords, explain what they are and how they can be used in order to solve the problem we had with the implementation of chaining constructors in the previous DrawingApp version 1.5. So the new version will be 1.6. And in this new version I'm going to demonstrate as well an interesting feature that you can implement with a class member, namely that of counting the amount of instances of a class. Before coming back to the problem, let me first, as a recap, explain how I implemented chaining constructors in the previous version. What was the idea? First of all, have only the constructor with most parameters invoke all the necessary setters. So I implemented 4 constructors: a default constructor, a copy constructor, a constructor with 2 parameters, and this constructor with 4 parameters is the one I'm referring to in this first item. So I have only this constructor invoke all the necessary setters. 2. Have the other constructors invoke that constructor by passing the necessary arguments using the this invocation. Let's have a look at the default constructor first. So from the default constructor we're going to call the constructor with most parameters by using this syntax, this, and then passing 4 arguments, and this will result in actually the constructor with 4 parameters being invoked. It'll invoke the 4 setters, after which we come back to the default constructor and then going back to the clients. And we can do the same with the copy constructor. The copy constructor as well invokes the constructor with 4 parameters, passing the properties x, y, height and width using the reference variable rect. And then the third constructor, invoking the constructor with most parameters, is doing a similar thing, passing 0, 0 and then the values of the parameters height and width. And so the other constructors must pass 4 arguments. This mechanism ensures that invoking a specific setter will not be forgotten. Back to the problem we had in the default constructor. If we uncomment the declaration of these 2 finals, then we get a compiler error. Call to this must be the first statement in the constructor body, because this statement must be on top of all other statements. We may not execute any statement before this, not even declare variables. And the reason is because at runtime we have to make sure that properties are initialized by executing calls to other constructors, if there are any, before doing anything else in the current constructor. And the problem is, well, I want to use those constants, but I can't do this. How to deal with it? Well, that's what I'll demonstrate in this new version by defining the final variables, the constants, as class member variables and use those in the constructors instead, because the compiler doesn't allow me to declare these local variables. Now, before looking at the solution, we must first understand the difference between an instance member and class member. For that, let's go back to the specifications of rectangle. We specified first that a rectangle is drawn starting at some position denoted by coordinates x and y, and a rectangle has a height and a width. Their values are expressed in numbers, say integers. And these 4 properties are specific to each individual rectangle. I can have, for instance, a small rectangle starting at, say, position 10, 10 for x and y, and with a height of 20 and a width of 30. I can have as well a big rectangle starting at position, say, 80 for x and y, and with a height of 400 and a width of 550. So each individual rectangle has its own values for those properties. The values can be the same, but the rectangles will still be 2 different rectangles. So these values are specific to each individual rectangle. And how do we translate specifications to Java? By defining data members, properties, as we saw earlier. As we saw earlier as well, we call these instance member variables. Now, the second thing we have to bear in mind is that those 4 properties may not have unlimited values. In order to be valid, they must fall within a certain range. Their values must be acceptable. For instance, I may not have a rectangle with a height of 1 million and a width of -10. No, the values of above mentioned properties must be validated against a set of acceptable values. And what were those values? The x and y coordinates must lie between a value of 0 and 1000. The height and the width minimum must be 10 and a maximum of 500. The variables we're going to define representing the minima and maxima for validating against the actual values of our properties are expressed in numbers, so in integers. Now the difference with the properties of before is that these minima and maxima are not applicable to a specific rectangle. No, they are applicable to every rectangle. In other words, I cannot have one rectangle obeying to those rules and another one having a height beyond any range. How do we translate this specification to Java? By defining the variables static, and you call them class members. Now beware, it's not about final. Final is just to make sure that the variable is initialized once and can't be changed afterwards. This is about static. Static values are, in other words, not linked to any particular instance of a rectangle. Instead, those values are applicable to every rectangle. Validations to check whether the values for the x, y, height and width properties are within range will be checked against the same static variables for all the rectangles. Now, I find the name static a bit unfortunate. Static might be associated with something that doesn't change, like a statute, for example. And in the context of a variable declaration, a variable whose value doesn't change after initialization, in other words, a constant. But in Java, there exists already a word for defining constants, and namely final. So don't mix those two. Final makes the variable constant. You cannot initialize another value after the variable has been initialized, but static makes sure that the data member will not be linked to any particular object. Implementing the solution of our problem, the solution is define class members and use those in a constructor. In our rectangle class, we define the minimum for x, y, height and width and use those in a constructor. And the problem is solved because we don't need to define anything anymore before the this invocation. So in a nutshell, a static variable allows you to define properties at class level, meaning that to take the minimum height, for example, if defined static, then it means that this min height specification holds for all instances of class rectangle. It's not specific to any particular objects. And since these variables are defined at class scope, it means that I can use them in any method or constructor of the rectangle class. Static properties are as well stored only once in memory because they are not part of any object on the heap. And this saves space, as I clearly demonstrate in the under the hood video of this topic. For those of you who want to know more about static, I have some videos about the topic in my other playlist, Stack and Heap Memory Fundamentals, in which I explain the difference between instance and class member using another example. So beware, don't define them as instance variables. Why not? Because by omitting the static, I make it an instance variable, and then every object will have 4 properties more, namely these 4: min x, min y, min height and min width. Again, have a look at these under the hood videos in which the difference is explained visually. And then the next stage is to use the class members as well when validating. Recall from the chapter about encapsulation and validation, where I implemented the setters. So what I did was validating the value of the parameter against some local variables, min height, max height. Those local variables are not necessary anymore. I'm using the class member variables instead. Min height, max height, I don't have enough space to add the value for the maxima, but assume that they are defined as well, as will become clear in the hands-on video. In the UML diagram, we add the declarations of the minimums and maximums and denote them as class member variables or static, underlining them. That is the UML specification. Another interesting and handy usage of class member variables is that it can be used to count the amount of instances of a class. So what I'll do is I'll add another class member variable, integer count, which I'll increment every time a constructor is invoked. So every time the client creates a new rectangle, will that count be incremented, and that way will it be able to obtain the amount of instances of the rectangle class. Why do we make count static? Because count is not an intrinsic property of rectangle, as are x, y, height and width. In other words, you don't need count in order to draw a rectangle. From an object structure in memory point of view, you could say that we don't need a counter per rectangle object. So no count field as part of the object. No, just one global field in memory, not linked to any object, is enough. It's public for now, but it should be encapsulated. See later. I'll address this problem in the next topic about class methods. For now I make it public, so we have the plus sign and as well underlined because it is a static member variable. DrawingApp 1.6, the clients. So first of all, note a new feature in the client code. We use a property of the rectangle class without even having to create an object first. And that makes sense because, as I explained earlier, static members are not related to any particular instance of a class. So that means that I can use those class members without having to create a rectangle object first. And this is what we clearly see. And how do we use class members? We use the name of the class, dot, and then access our class member. Now again, we can do this because our count member is public, but we'll make it private and actually encapsulate the count member in the next version. For now, I keep it public. So what I first do is display the amount of rectangles that are created. Then I create a few rectangles, 4 in total, and at the end I display the same count again, resulting in the following output. So first of all I have 0 rectangles created, then is displayed the output of the 4 rectangles, and since we have created 4 rectangles, will the count be 4. Time to put all this into practice in the hands-on video. So as usual, I create in the package module 1 classes object lib. I add a new package demo 6 class member variables and implement my class members in the rectangle.java. And in the app package, I'll add a package demo 6 class member variables as well and test all that in the DrawingApp. That's it for this introduction. Hope to see you in the hands-on video or the under the hood version. And if you like this presentation, thanks for pressing the like button or subscribing to my channel.